Hello robotic friends, today I would like to introduce you to the construction and functioning of a PM6600 power module of a KUKA KRC1 robot controller. Anyone who has ever worked on such a PM6600 can imagine that I don't do it voluntarily because it involves a lot of screwdriving. But my module is defective and I'm currently troubleshooting it. So this gives me the opportunity to introduce you to the module. Okay, let me explain. In principle, the PM6600 is a frequency converter, or to be more precise, 6 frequency converters for the respective motors, which means that the 3 phases of a 400 volt 3-phase supply are rectified to a common DC link voltage of up to 600 volts. And from this DC voltage, a low-frequency 3-phase supply is then produced for the individual motors with the help of pulse width modulated signals. The great thing about the PM6600 is that it's very modular. Each individual board has its specific function, and at least between the last two models, the interfaces between the boards are the same. So it's quite possible to mix the boards between the two models. Only one of the boards of the power supply has a small limitation in terms of installation, which can however be overcome, but I'll come back to that in a minute. Okay, I think we are finally ready to get into the details. I have already indicated that there are two power supplies in the upper part of the module. The high voltage power supply at the bottom that produces the DC link voltage, and the low voltage power supply at the top that produces a whole range of different DC voltages to operate the rest of the electronics. Up here you can see the so-called logic board that establishes the communication to the industrial PC, monitors the entire function of the module, and establishes the PWM signals for the individual driver cards. I have done some preparations so that I can remove the logic board relatively quickly to give you a look at the parts underneath. What you can see now are the 6 driver cards, each for one of the 6 motors to control the 6 IGBT bridges. You can also see these mighty electrolytic capacitor boards that are intended for smoothing the DC link voltage. Don't be surprised if you see a couple of capacitors more than usual. I added 2 more for testing purposes, because interestingly there is an additional space provided. Underneath is the so-called mainboard, which I'll come back to in a minute. Okay friends, perceived 300 screws later, you have a view of the almost naked PM6600 with the large heatsink at the bottom and the various IGBT modules screwed on it. You can see the compact modules for the A4, A5, A6 axis with the complete IGBT full bridge inside, and for the axis A1, A2, A3, 3 identical IGBT bridges that together make a full bridge. As mentioned before, you can see now why the high voltage power supply is only partly interchangeable between the two models. Simply the position of the components that need to be cooled is slightly different, and the height is also different, which means that the spacer bolts would also have to be replaced, but it's not impossible. On the newer model, the screw positions are provided for both, so you can fit both boards in the newer enclosure if you change the spacers. In the older model, however, there are no screws to fix these two components to the enclosure, but everything is within the realm of possibility. As you can see, I have partly reassembled the PM600 in the meantime, and you have a view of the so-called mainboard. All the signals converge on the mainboard, but there are comparatively few components on the mainboard. Actually, you only have the electronic current transformers, 2 per motor, and the short circuit relays that short circuit the motor when you press the emergency stop and when you don't move the robot. Other than that, you just have a couple of suppression capacitors and a couple of resistors from the current measurement back to the logic board. Beside that, the mainboard is really just making connections. For example, comes here the low voltage power supply to the mainboard and goes to the individual driver cards. Via the connector here, the logic board reads the measured current values directly, so the current values go directly up to the logic board. Here the individual PWM signals go from the logic board to the driver cards. The relays are normally closed, which means they have to be activated before the motor can be controlled. Otherwise, there would be a short circuit immediately. The relays are connected in parallel and are supplied with 24 volts via 2 pins here, so that they open symmetrically here on the other side in the same way. I think that's it for the main board. Here is, by the way, the DC link voltage that goes to the main board. The relays are installed on the motor side behind the IGBTs. As soon as you press the deadman switch on the teach pad, the DC link voltage is switched on. But only when you move one of the motors, the brakes release, the IGBTs are activated, and the relays open so that the current flows through the motors. I have reassembled my PM600 so far. I hope this has given you some insight and maybe it will help some of you with the repair. Don't hesitate to leave feedback. See you. Bye bye.